We gotta make this fillet.
Brother?
I know y'all know you sleep with them.
Oh, yeah, I'm gonna be out with my headphones in.
Alright, everybody got stuff put away? Karen, you got stuff put away back there?
I think it's just 1 week. Are you going?
That's what you get.
I never feel soda because I have a brain soda. Can I write on this now?
Yep, that's why I gave it to you. Alright, the quiz has started. No one should be talking. Alright, you may write on your periodic table, draw your chart on the back if you want the arrow chart, whatever you want to do with it. Let me grab the quiz paper.
Do we need to write our name?
Let me see if I can get them off. Maybe just make that worse.
You want us to write our names on this?
Nope, we're gonna throw that out.
Yes, ma'am. This is Miss Wall. One of my students spilled sweet tea all over my floor. When the custodian has a moment, do you think they could bring a bucket down here? Because we're, I'm sure, going to have ants by the thousands in an hour. Thank you, ma'am. We're calling their friends as we speak. I try. No, hold back on that one.
Sweet tea? Yes. Great.
I see it's out there.
Which we do that for.
Don't worry. It's a lifestyle.
I already know it. Don't worry.
Where do you work at?
I don't work there no more.
Oh.
And not because I couldn't
You
mop.
know how to mop. Well, so ain't that mop.
So where did you work? She did all the spots. The ants are calling their friends. The whole herd is coming.
Lord have mercy.
Just keep coming up.
Unfortunately.
She only lost an inch out of the cut.
Well, you asked how much she was on the war, and I gave you an answer.
I'm just giving you a hard time. Chill.
All right, love it.
Thank you, sir. Since you go back to the chair, so then get wet.
You mentioned it. I'd come first and first.
No tell what's in that water.
Good.
How many of you are still working, just so I have an idea? Okay. Who's still working now? I got 2 or 3 minutes, that's better.
Who's still working now? Anybody? Or are we good? Alright, let's approach to the front. I do not need the periodic table, just the quick stuff. Y'all can throw that away. Unless you just really want something in there. Put it in recycling, put it in the trash, I don't care which. Alright. Now, we're going to do Kahoot next to practice with your quizzes on tomorrow. Some of you, I'm sure, have not looked at the other periodic table. Even though y'all are hollering that, Miss Mom, that's too much to know for tomorrow. So, grab your phone, or the laptop card is already unlocked. So grab a computer if you need a computer or would rather have it to play. Sometimes our phones working through the school guest Wi-Fi can be a pain. So put in your legit name, not some stupid name. Okay? We should have 17 people playing. Sophie's not here, and somebody else. Who's the other one? Yeah, John.
Come on, Diana, go ahead. You started off.
All right, we're going down. We're going the wrong way. All right, we're back up to 16. Who are we waiting on? There we go. All right. A group of silicon in. Yeah, you need a periodic table. Come on, dudes. Said this was to review the periodic table, Liz. What do you think you needed? And I tried not to make the time real short so you had time to locate the elements. That does not mean we need to take the entire minute that I allot. What is that? Oh, all right. So, silicon. Meter stick out. Not bode well for quiz tomorrow. At least nobody picked group 18. All right, 3, at least is a period. Group 1, right? Group front up and down. Group 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, group 14. Now, those of you who pick 3, pick the what? You pick the period. It's in period 3. I have no idea what 6 is. The two of you who picked 6, did you just accidentally touch the wrong thing? All right, what's the name of the colored section that's going to pop up? Okay? What's the name of that colored section? This should be an easy one.
Xavier, leave me alone.
The worst.
Oh, okay, I'm 60.
All right, very good.
Leave me alone.
All right, what period is calcium in? Good. It's the kind of results we should be getting at this point. Which of the following is a liquid?
Oh.
Good.
I'm thinking about it. Here's one for you.
Yesterday.
He got it.
Oh, he already color coded one? Oh, you did your own? Oh, I gave it to you?
I'm not worried.
Well, that was very forward-thinking of me. All right. All right. What's the name of the colored section? All right. Now, how many of you are doing this with the color-coded table we did yesterday?
Yeah.
Can you do it without it?
Yeah.
Yes.
Okay. If you can do it without it, you should be fine on the quiz. All right, the carbon family starts with what element?
I moved up.
Starts with carbon. Okay, so maybe that person just touched the wrong thing on their phone. Which of the following is a non-metal?
It's a big frog.
Dan's called. I trust you.
They can start making better cups.
I feel like, no, because they just have a lot, like, when it pops off of a lot.
Oh, Jackals are even worse.
Yeah, I can't stand that, like, you pick it up.
Alright, that's because they got a weak cook.
All right, which of the following is a non-metal? Where do you have to be a non-metal?
The right.
The right. The right side of the staircase. Calcium is where?
It, like, clicked it.
It's on the left, so it's a metal. Now, maybe you're like Tiffany and accidentally clicked the wrong one because she said it clicked at 4. And maybe that's why I got 2 people who said metals. Arsenic is on the staircase, so it's a what? It's a metalloid. Okay? So it cannot be a non-metal.
It just means that.
All right, which of the following is a metal?
I don't have this. Well, it could be worse. It could be that, but it's like,
Oh.
totally the wrong answer.
So dumb.
Dang.
I clicked the wrong one.
God, I clicked the wrong one too.
I get that a lot.
No, I did.
It's got too much time on it. Though.
Yeah.
It should.
Maybe the worst thing that I.
Oh, except carbon over there has the wrong number. It's got the mass instead of the atomic number. I need to fix that one. Remind me to go in and fix that one in a minute when we finish this. And I need to fix the one that says which of the following is a metal. Carbon has the wrong number.
Oh, yeah.
Right, I'll be good.
I'm behind someone.
I'm behind you.
Yeah, that's I'm gonna stay behind you.
Well, then-
Shut up.
Shut up.
Come on, next.
You got scared, dang.
Next.
You can't fight.
Stand up.
I ain't gonna do it.
No, we don't.
I should not know that.
Oh, no.
I see, I could be there. I knew.
Right, that's all I told you.
Yeah.
Okay. I thought it might have to do with the SPD.
I'm not.
That's the thing.
I told you not
We
to.
have a little problem here.
Baby.
Anybody see a problem besides me?
Yes.
Yes.
Which is a metal? Now, I would love to believe that 5 of us accidentally clicked the wrong thing on the
I
computer.
told you.
Yeah, that's what happened.
I know.
I
Okay,
accidentally
so all 5 of us clicked the wrong thing.
Yes. Yes.
Okay, really?
Yes. I know carbon ain't no metal.
Okay. Okay, all right. If you say that, okay.
I know that.
But I'm gonna be disappointed tomorrow if I ask a question like this on the quiz and I get a whole bunch of people who put the wrong thing down for a metal. Okay? Because the left side of the table is not gonna have carbon. Helium in particular is a what? It's a noble gas. And 2 of y'all picked it as a metal. That better be I clicked on the wrong thing. We got an answer there?
Yeah, that's a big one right there.
Big what?
And
Gonna carry her away?
I'll talk about the stool.
What's wrong with the stove?
Jay, so he was talking about you. You keep looking at it.
You the
I said
ass.
it's a
He
big
said
area
you
right
was
there.
shut up. And we're saying.
Did y'all watch her during the quiz?
And you.
And she kept pushing up.
Yep, you should have watched her during the quiz.
Started with that, I'm behind that. Let's catch up.
It was quite entertaining.
Come on now.
Which element has 1 electron in the outer shell?
So late.
Oh my God, I pressed the wrong one.
Maybe you should think about getting rid of those nails. Maybe that's the problem. The nails get in the way.
Okay, look, this chair kind of.
What's wrong with the chair?
Yes, oh, yeah.
She broke it.
You broke my chair?
She broke the stool.
Are you kidding? First, you're making a mess with the tape. Now you're breaking the furniture?
Hold on, y'all.
Now y'all. You weigh what? 90 pounds soaking wet? And you broke a stool?
Hey, what place you in?
Really? Not even in the ballpark of a stick.
Oh, yeah, Jay, you funny.
Right.
Jay, you funny. You think?
Now, how do we figure out outer shell electrons since 2 people got it wrong?
Okay, first column is 1, the second column is 2.
1 electron in the outer shell, which is why 15 of us got it right. Magnesium has how many? 2, and then aluminum has how many? 3. You try not to fall off and hurt yourself.
You ever play Fortnite?
Next, it's gonna look like she's gonna be on the floor.
Alright, next.
You ever play Fortnite?
Which is the following metalloid? Y'all try not to hit the wrong buttons this time.
I clicked the right one.
That's very good.
Yeah.
You ought to be getting better at this.
I think we're at the hang of how to put the
I'm coming in swinging tomorrow.
Okay.
Alright, so we only got one person who picked gallium.
It was probably Zay.
Gallium's too far to the left. Alright, what's the name of the colored section? What's the name of the colored section? Alright, what happened to number 17? We get kicked out of the game?
Can you leave me alone?
You can't go beat me so much.
Alright, which element's a lanthanide?
First
I got it.
Oh my gosh, dude.
Dude, my phone's frozen.
My phone can do that too.
Pick Colorado.
No,
What
the heck? Zay, you leave me
I
alone.
ain't say nothing to you.
what place you in?
10.
Alright, arsenic is up there on the staircase. Arsenic cannot be a lanthanide, it's on the staircase. What period is iron in?
What's she doing? I got it wrong. Oh, okay. I'm stupid.
We know.
Your mama daughter. Your mama son some more.
No, you won't listen. Yay.
Give me some.
Come on next. That fish over here. Other side. Thank you.
Good. That is that. It's good. I don't know what's in it. Ugh.
What they make?
You gonna mix the two. This one tastes good. I don't like that lemonade.
The big group.
It's too.
Yeah,
I like the other one. The pink. Have you tried the green apple? I don't like green apple.
Alright,
I like that pink.
so the four of you who picked 8 picked the what? The family or the group? 1, 2, 3, 4, 5, 6, 7, 8. Pick group 8. Okay? 1, 2, 3, 4. It's in period 4.
Don't lie to me.
Alright.
He said a lot.
Which of the following is a gas? Got 2 more to go.
You say you know everyone.
The following's a gas.
So you say.
Who said it?
Oh, answer the question, Xavier.
I answered it.
Okay. Stop arguing.
I wasn't arguing. I said, who said something to you?
Why are you telling her the answer? There's no grade attached to this. Let her find her own answer.
Aaron, get it wrong.
Xavier, turn around and leave me
I wasn't even
alone.
looking at
He
you.
messed with me all last week. When I get mad, it's gonna be.
I'm in fifth
I can't even take you serious.
Alright. I don't know why we picked carbon again. Carbon is a solid. It's a pencil.
It was not. I got it right.
And lithium is a metal.
Okay, we get it. You got it right.
Alright, last question. How many outer shell electrons does sulfur have? I don't think your mama has outer shell electrons. I'm pretty sure anyways.
-2.
Oh, darn it. Oh, no, I ain't here. Yeah, I think I got it wrong.
What you put, Jay?
I'm not. Yeah, I got it wrong.
You put -9.
All right, those of you who picked the -6,
Just got it back.
it's just 6. It doesn't have a negative sign.
I have.
The -2 is the oxidation number, not the outer shell electrons.
Exactly. When I get up.
All right, if you have a laptop, go put it away. All right, if you have a laptop, go put it away.
Xavier just keep bullying me today.
Really?
Yeah.
Stop with that mess. They really were big.
What did I do?
I have no idea. Stop.
Well, you're bullying me.
I sincerely doubt he's bullying you. He probably is being annoying.
Yeah, he is annoying.
Have you ever seen,
Shut up.
you shut up.
Oh yeah, shut up. Miss Wall doesn't want to hear it at this point.
Why you scared?
You ain't gotta be scared of me.
Scared look.
Nobody said you were.
Stop. Stop. Your mama's scared looking.
Mama daughter scared look. Shut up.
You
Shut up.
so much.
Shut up.
You lying.
Shut up.
You
Oh
lying.
my God.
Would you leave him? Because you would not have gotten up and run back. If you had not gone over there.
I was throwing
Be
my,
afraid.
I was doing something like
I had to fight for my life.
yeah, you got to get beat up and throw in the trash can.
Yeah.
Oh my God.
Oh, what you got to show me? Oh,
Shame.
I already seen it. I already seen it. Right, like, it's over. Let it go, boo. Why you want that hurt your bar? Look at me.
Why you smell like
Everybody,
you've been right by your face?
no, my car smells.
Yes.
Why did you ask me if I saw it?
Because there are a few people who didn't, and I wasn't going to answer.
I think I took it out.
Okay.
I hope so. If not, you just got a free chance to look at it. All right. Go.
Oh,
So you can get back.
that's not what you do when you go.
Oh. I just need her to deliver it. Now, we're going to talk about the. That was way too wide. We are. We're going to talk about the relationship between outer shell electrons and oxidation number. Now, this will lead us into a discussion about reactivity and eventually to the periodic table. Unfortunately, spring break really falls at a bad time because we would be ready to test on Friday. Now, because spring break falls where it falls, we will test on Tuesday when we come back. I will not test the Monday we come back from break. That's inherently unfair. I don't plan to do a bunch of schoolwork while I'm off on break. I'm not going to ask you to do a bunch of schoolwork while we're off on break. However, it is your first big test grade of the quarter. You know what your grades are in here. You know what kind of average you want. I will tell you the second test grade of the quarter typically and historically just flat sucks. Okay? It is the one test grade that I would allow test corrections on.
So the second one?
The second one. Okay? It also has 78 questions on it. Okay? So, when you come do test corrections, in order to make a dent in the grade, can you just come do 3 or 4 test corrections to make a dent?
No, those of you who are mathematically sound know that in order to raise your grade, you need to do what? In 78 questions, do they count very much? No, so you got to do a bunch of them to get some points back on that kind of test. So if you want to do well and keep your average up on this next test, you need to do reasonably well. Now, that said, if we were testing this week, I would think that we would score pretty well. Going home with a week plus a break in between now and when you test, what's going to happen over that time?
Don't forget.
We're going to forget.
Or we're gonna study a lot and be super.
That's not what's going to happen.
Okay.
Okay? Now, I can't fix it for you. I can't move break. I can't get the test in before we go home for break. So it's up to you to do what you need to do. Okay? I'm just telling you where the test falls. There are no test corrections on the test. I give you test corrections on chapter 5, the bonding periodic table test, which you're going to need if you want to have test corrections. So on this test, it's up to you to do what needs to be done. Okay? So that's where we're sort of going with this. That's where the test is going to fall. So we're going to talk about electrons and how they relate to oxidation number and where it comes from today. And then we're going to tie it in to what we've done with quantum numbers and the periodic table over the next 2 days. Those of you who are going to New York, I know I've got a couple people, you asked me, are we doing anything Thursday? Yes, we're tying all this in together and we're practicing. So you're going to miss that kind of stuff on Thursday. We're not coming in just to sit. Those of you who are absent, it'll be on YouTube. It is a lot of practice and tying together and asking questions. Now, Xavier will tell you, if you come pester me during my planning period, I'm not especially nice and I'm not going to give you my planning period. I get a little testy. Now, when we look, and the Monday we come back before the test, will I have that Monday to be able to stay after school? Because I have a what? What kind of meeting? Staff meeting. Let me a staff meeting. It's the first Monday of the month. All right, or that we're here anyways. So the relationship between outer shell electrons and oxidation numbers. To do this, we need to look at group 1, and we're not going to do all groups 1 through 18, so don't panic on me and think, oh my God, this woman's going to do this for all 18 groups. No, I'm not. We're going to look at the patterns. We're going to do group 1 and group 2. After we do a couple groups, some of you are going to be like, oh yeah, I get it. Some of you might need a couple more groups to get it, but you're not going to need 8 groups to be able to get it. So, if we look at group 1, okay, I'm going to write the most configurations in group 1 to illustrate this. So hydrogen has a configuration of 1s1. Lithium,
You want us to write this down?
I would. I'm going to use it.
Sometimes you write stuff down and you feel you want to write it down.
I usually say that, but. Okay. Like I said, I was writing the most for group 1. I will not write as many for the remaining groups in the ones we're going to do. Now I'll let you catch up with me. All right, got it? Yes? No?
No. Okay. What's the highest energy level in hydrogen?
1.
Okay. What's the highest energy level in lithium?
2.
What's the highest energy level in sodium? What's the highest energy level in potassium?
4.
And in rubidium?
5.
And in cesium?
6.
Now, first of all,
Why are all these elements in group 1?
Because they have one electron.
Okay. All elements are in, and when I write G1, I'm referring to group 1, okay? Because they have one electron in their outer shell. So, multiple times throughout the course of the last week, 2 weeks, people have said, why is hydrogen in group 1? Several people have asked it since before the last 2 weeks. Hydrogen is a what? It's a gas. Or you could have said non-metal. I would have been happy with either answer. Okay? It's a gas. It's a non-metal. All of these things are what? All of these things are metals. All right, so why would we put hydrogen, which is a gas and a non-metal, in a group with all metals? That is the answer. Okay, the reason hydrogen is in group 1 is because it has what? One electron in the outer shell. The periodic table is designed based on electrons in the outer shell. Everybody in group 1 has one electron in the outer shell. It is the only place on the periodic table that has one electron in the outer shell. Does that make sense? So when we called them the alkali metals yesterday, did I color hydrogen as an alkali metal? No, I left it white and I colored the rest of the group a color to be the alkali metals, but not hydrogen, because hydrogen is not technically an alkali metal. It's in that group because it has what? One electron in the outer shell. Everybody good with that so far? Okay, so we want to talk about how they get their oxidation number. Now, this comes from their Bohr model. So I'm going to draw sodium. Okay, we're going to use sodium because it's a nice size, but it's not ridiculous in terms of what we would have to draw, because, you know, I don't want to get crazy and draw a bunch of crap. Because I'm like y'all. I'm a little on the lazy side too. Here, let me pick another color. I know. Y'all are thinking, who y'all calling lazy? So we have 2 on the first ring, 8 on the second ring. All right, so some of y'all might have learned those rules way back in middle school. And some of y'all undoubtedly remember when I told you those rules a couple weeks ago. Now, you should be able to explain to me why those are the way they are. Can anybody tell me why the first ring has 2 electrons on it? And the S sublevel holds how many electrons? That's why. So why would the second ring have 8 electrons?
I mean,
you got a little bit missing. You're warm. Clean it up a little bit. The second ring has how many energy levels? Okay. So how many sublevels would it have? I heard it. 2. So what are their names? So how many electrons can go in S? How many can go in P? So what do you get when you add S and P? That's why it's 8. Okay? So Tomas just said 6 because he was just thinking about P, right? But you got to add the S and the P. So 2 plus 6 is 8 combined. Does that make sense? So if we had a 3, technically 3 can hold how many electrons? 18. Now, this is what I'm talking about after Easter goes by, or break goes by. We stopped doing this last Friday-ish, right? Today's Tuesday. It's only been 4 days. And y'all are already struggling with how many electrons are in N equals 3.
you said N. If you would have said N, I would have got it. Because I remember 2 and
Right. But I just said the third ring and the third energy level. Am I always going to say N equals 3 on the test? No. I might just say how many electrons are in the third energy level. You got to translate energy level into N equals 3 into
18. You got to put that together. Okay, that's what I'm talking about. We're going to be working on some tomorrow and Thursday is making those connections. Okay? So, now, looking at this. We have how many electrons on the outer shell? 1 electron in the outer shell. Now, does anybody remember what all atoms want to achieve? All right, some of y'all have goals, okay? When I was in high school, my goal was to get a college education. Some of y'all might want to get married and have kids. Some of y'all, Xavier wants to go in the National Guard, probably, so he can get college funds and go into a good school. You don't tell them what some of y'all want to do, okay? An atom, single focus. They want a certain number of electrons. Anybody have any idea what that single number of electrons is?
8.
Well, it's 8, okay? All atoms want 8 electrons. There are no exceptions to that rule. They want 8 electrons. For the purposes of our discussion today, there are exceptions, by the way. All right, lots of them. There are more exceptions in chemistry than I could list today. Now, how is it going to achieve 8? Okay, that's where we're going with this discussion. How do you get 8? So, what are my options? I have how many electrons in the outer shell? I have 1. So how can I get 8 electrons in this outer shell? I could add 7, okay? I can gain 7 electrons. That will certainly get me 8. Or I could do what else? I could lose the 1 electron that I have. Okay? Now, Tomas has got this, what's she talking about? Look on his face. How can I lose an electron and yet wind up with 8? Well, look at where that 1 electron is. Where's that 1 electron at? It's on this outside ring, right? So, if I take and I lose this outside ring, I'm going to redraw it, by the way. All right? I'm going to lose that outside ring. Now, all right, I erased this outside ring right here. I just erased it. All right, it's gone. Now, this is my new outer shell. Now, if that's my new outer shell, how many electrons are on my outside? 8. So by losing that 1, how many do I have on my outside? 8. So what's easier for an atom? Is it easier for an atom to gain 7? Or is it easier for the atom to lose that 1 to somebody? It's much easier to lose 1. So the atom is going to say, let me just give my electron away to another element, which is where our topic of bonding will come in after break. Okay? We'll talk about who it likes to give the electrons to, because it doesn't just give them off to the air. It finds an element it likes. Okay? So, sodium will like to find an element that's willing to take that 1 electron.
So when you said all electrons want 8, all atoms want 8 electrons, you meant in the outer shell?
In the outer shell, yes. They all want 8 electrons in their outer shell. How they go about getting that, that's how they get their oxidation number. So, if they lose 1 electron, what is their oxidation number? So, the oxidation number will be 1 because they lost 1 electron. Now, will it be positive or will it be negative if they lost an electron? That's what everybody always tells me. It's positive. Now, why is it going to be positive? Okay, it has 11 protons. And it had 11 electrons, right? But we lost 1 of the electrons. Now we have how many electrons? We have 10 electrons. So think math class. What happens when I add 11 positives and 10 negatives? You get a positive 1. That's why
it's an oxidation number of a +1 because you have more protons now and you have less electrons. That's why it's a positive oxidation number. So we have more positive charges and less negative charges. Are you with me? Yes. Okay, let's do another group because I know some of you are not. Okay? It's not hard once we do a few groups and you get the hang of what the explanation is. Okay? Everybody caught up? So I can turn the slide. All right, so if we look at group 2, for example, and I'm only going to draw 2 or 3 configurations this time. Let's do BE, which has HE, 2S2, and then MG is AR, 3S2, and one more. CA, which is, oops, neon. I skipped neon there and put neon. Sorry. I knew I was off when calcium was supposed to be AR and 4S2. All right. So when we look at these, again, what can you tell me is the highest energy level for beryllium?
2.
Okay. What's the highest energy level for magnesium?
3.
And for calcium?
4.
So, again, why are these elements in group 2? Okay. They're all in group 2 because they have 2 electrons in their outer shell. Does that make sense? Okay, that's why they're there. None of these elements can be in group 1. They can't be in group 1 because they have how many electrons in their outer shell? 2. They can't be in group 13 because they have 2 electrons in their outer shell. Their outer shell electrons place them in a group. Does that make sense to y'all? Yes or no? Okay, it should, but I just want to make sure. Okay, from there, suppose we draw magnesium this time. All right, magnesium has 12 electrons. Okay? I forgot to fix that carbon. I need to do that. All right, so it's just like sodium. It has 3 rings. So 2 on the first ring. This time, 8 on the second ring. One, 2, 3, 4, 5, 6, 7, 8. And 2 on the outside ring. Now, all total, my dots have to equal what? I mean, aside from the fact that I'm Miss Wall and I know how to draw these, how do you know how to draw these? How many dots do those have to equal? Does everybody know? I'm just assuming. Y'all know. They have to equal what number?
The number of AR plus the 2.
The electrons, yeah. I mean, Tomas is right in that he's adding up AR and the 4S2 if he's doing calcium, but we're actually doing magnesium, so Ne plus 2, which would still be 12. Okay, the number of electrons, basically. Okay, so how many electrons are in my outer shell?
2.
And I need to get to what number?
2.
So how can I get to 8? How can magnesium get to 8? All right, I can gain 6 electrons because these 2 plus 6 would give me 8, right? Or I could do what? I could lose 2 electrons because if I just erase these 2, my new outer shell is going to be what? Those 8 that are on that second row, right? Can I do that real quick? Everybody got it? So if I erase these two right here, my new outer shell is those 8. Whoop, it's crap. There's no undo button. Dang. All right, I need a little more practice.
Why do you want to lose 2? Don't you need 8?
I do.
But isn't there 12?
Hold on.
I know I get the 6, but you're losing 2 and there's 12.
Okay, so I need 8 on the outer shell, right? So if I lose 2, let me get rid of this without hopefully erasing the whole model again. If we lose these 2, now what is my outer shell? That's why we lose 2. Because this is my new outer shell. Okay? And my new outer shell has how many? 2, 3, 4, 5, 6, 7, 8. So when I lose 2, now I get 8 on the outer shell. Okay? So if I lose 2, now what's my oxidation number? What's my oxidation number? Positive 2. Does that make sense to anybody other than me? Yes? Okay. Because the pattern is the same. It doesn't change. Ashanti, you with me? Okay. My quiet people got to speak up if they're not with me. Okay. The number we lose tells me the oxidation number. So since we lose 2, the oxidation number is 2, and it's positive because there are 12 protons and only 10 electrons because we lost 2, right? So you got 2 more pluses than your electrons, which is why it's positive. You have more protons, more positives. Okay? It basically, and you can also do it this way, Tiffany. If you lose electrons, it's always positive. Yeah. I see a hand over there.
Yeah, I'm gonna have to get water.
Okay.
I got a question.
Yeah.
How about for groups 13 from 8?
We're getting there. So we're jumping to next. All right. Everybody go group 2. All right. So we're jumping over the transition elements. Because what I tell you about the oxidation numbers for the transition elements, they vary. Okay. The oxidation numbers in the transition elements vary because those are your D block elements. They don't have complete shells in the D block. So those are the ones that have Roman numbers of like +2, +3, +1, +2. Manganese at +2, +3, +4, +5, +6, and +7. Okay. Your curriculum is not to figure out how to find multiple oxidation states in the transition metals, nor am I planning to teach that today. Okay. So we're jumping all the way over to what group? We're jumping all the way over to group number 13. Okay. In a first year class, we normally focus on what's called main group. Main group is group 1 and 2, and then 13 to 18, or the S and the P block elements. Okay. We'll do some transition. We will not do a ton of transition stuff. So group 13, okay, we're just going to do 2 this time. Aluminum is neon. Huh? Just 2. And then gallium is AR, 4S2, 3D10, 4P1. Now, even though gallium has a D in it, it's still going to be how many electrons in the outer shell? It still has 3. Okay. So there are 3 electrons in the outer shell. Now, do we need to draw the Bohr model?
No.
Got it. So if there are 3 electrons in the outer shell, how can we go about getting to 8? Okay. We can gain 5 electrons. Because 3 plus 5 will get us to 8, right? Or what else can we do with those 3? Or we can lose 3. Now, what would be easier for the atom? It'd still be easier to lose 3. So, if we're going to lose 3, what is our oxidation number going to be? Everybody with me on that? I told you, you get the pattern that we have going here.
How do you know how many electrons are put on the shell? Whatever you call it.
If you're drawing a Bohr model, the first ring can have how many? First energy level has how many sublevels? N equals 1 can have how many sublevels?
I don't know. I'm confused now.
This was what we did last week. So, if N equals 1, you can have 1 sublevel. What's that 1 sublevel's name?
I don't know.
What are the 4 sublevels' names?
I don't know.
S, P, D, F.
You said that wasn't the name.
This is the names of the sublevels. Yesterday, you and I were talking about the 4 quantum numbers. Okay, so the sublevels are S, P, D, F. So an S sublevel can hold how many electrons?
2.
So we draw 2 electrons on there. Now, a second ring is a second energy level. So a second energy level can hold how many sublevels?
What is it? S, D?
S and P.
Oh, S and D.
So S can hold how many?
2.
And P can hold how many?
6.
So 2 plus 6 is,
8.
that's how I knew to put 8 on the second ring. 2, 3, 4, 5, 6, 7, 8. And I haven't been doing things with very, very big numbers. So let's just say we're doing aluminum, which has 13 electrons. Okay? So we had 2 and 8, that's 10, right? So if I have a third ring, I only want 13, so how many more would I need on this third ring?
3.
So I just put 3 there. That's how I was drawing the Bohr diagrams. Okay? Now, I won't ask you to draw a Bohr model. I may ask you to read it and tell me what element it is or what group or period it's in, but you just figure out it's aluminum and then you can figure all that stuff out. Okay? Are you okay with lose or gain an oxidation number?
Yeah.
Okay. All right. So what happens then when we get to group 14? All right. So when we get to group 14, I'm only writing 1 this time. And we have silicon. Okay. This time we have how many electrons? We have 4. So this time, is it easier to lose or gain 4 electrons?
Either side.
We can't say, can we? No. Okay? Because we can't say, okay? Since the answer is either, the oxidation number is positive or negative 4. Okay? That's why yesterday when we did the trend, I wrote positive or negative 4 because it really can be either one. Okay? You can do either, lose or gain. So, what's going to happen after this group? It becomes easier to do what now after we pass group 14? It becomes easier to gain electrons because now we're going to have 5. Has everybody had an opportunity to catch up, or do I need to wait? Huh?
Since on the oxidation sheet
Mhm.
it has 2 wells.
that means it has multiple oxidation states. And that comes from the fact that you can lose electrons out of S and P based on where the electrons are in the sublevel. I'm just not going to explain that today. I would if this was an AP level class, but it's not. All right, so if you have group 15, okay? Group 15, if we did just phosphorus, for example, you have Ne, 3s2, 3p5, sorry, 3p3. I'm already answering how many outer shell electrons. How many outer shell electrons do we have? Okay, so there are 5 electrons in the outer shell for everybody in the group. Even though I'm only drawing 1 electron configuration, everybody in group 15 has how many electrons in the outer shell? 5. Nobody else on the periodic table has 5 electrons in their outer shell, or they'd be in group 15. So this is the first time that we've had a configuration that has more than 4. So this time we have choices of lose 5 electrons, or we can do what? Gain 3. So this time, what would be easiest for us to get to the magic number of 8? This time, it's easier to gain 3 electrons instead of losing for the first time all the way across the table. So if it's easier for us to gain electrons for the first time, what's going to be our oxidation number? Our oxidation number is -3 this time. All right. Why is it going to be a negative number? That's right. This time we have more electrons and we have less protons. So if you actually want to talk numbers for one like phosphorus, phosphorus has 15 protons. If we gain 3, we would have how many? We'd have 18 electrons. So when we add those together, what would we wind up with? What would happen if we add that together? You would actually get a -3. That's why it's a -3. Okay? Does that make sense? Tiffany, you with me? Or you just zoned out? You sure? Okay. Everybody there? Okay, because I'd really like to finish the last 3 groups here in our 10 minutes. All right, so group 16. This time without a configuration. Group 16 has how many electrons in the outer shell? It has 6 electrons in the outer shell. Okay, so if it has 6 in the outer shell, what 2 ways can we go about getting to 8? It can lose all 6 or gain 2. What would be easier for the elements? It's going to gain 2. So if it gains 2, what's its oxidation number? That's right. So the oxidation number is -2.
How do you know you gain?
You're going to gain anytime you have more than 4 electrons. Okay, so if you have 5, 6, 7 electrons, it's easier to gain. It's easier to lose when you have less than 4. And we're going to tie this together tomorrow when we put it on when I draw a periodic table. We're going to summarize. We're just not going to have time today. All right, so group 17 has how many? 7 electrons in the outer shell. So what can it do? It can lose all 7, or it can gain 1. What is better for it? Easier to gain 1. So what's its oxidation number? -1. Now, what's going to happen then when we get all the way over to the noble gases? That's right. That's right. All right, is everybody caught up? All right, have I given everybody enough time now? Okay. So the last group is group 18. Group 18 has how many electrons in the outer shell? It has 8 electrons. It has what we call a full outer shell. It has a name. We call that an octet. Okay? An octet stands for 8. Full, outer shell, and octet are terms that you will see regularly. It applies to the noble gases or group 18. Now, because they have 8 electrons, do they wish to gain or lose any? No. They will not lose or gain electrons. So since they will not lose or gain electrons, what is their oxidation number? Their oxidation number is 0. They finally form compounds with fluorine sometime in the early 90s. They were called the inert gases for a really long time, and they got the bottom 3, krypton, xenon, and radon, to form compounds with fluorine. The top 3, neon, helium, and argon, to my knowledge, have still not formed compounds with anybody. Yes?
So how would helium have 8?
It would not. That's why I said it has a full outer shell. We refer to that one as just being full because it can't have an octet. Okay? That one is an exception. We just refer to it as being full, which is why it's also a noble gas, because it has a 1s sublevel, and the S is what? It's full. Okay? Now, for homework tonight, because I don't think I have time to do the last thing I want to do with this. What is our homework this evening? For what? How do we feel like we did on today's quiz? Decent. We felt like we got 100. I'm not going to be upset when I grade these later today. I'm going to feel good about them. Now, they'll go into Power School. You should be able to check them later today. You will have to change the